What I want to do is I just kind of want to see what's happening with our variable that we're counting. I'm going to simplify this even a little bit more. I'm just going to call this an int just to make it a little bit more simple to read here. So we're going to start with our variable x. X equals 0. That's our starting value. We're going to run through this until x as long as x is less than 10. And we're going to increment by x by 1 every single time. Inside here, we're going to delay, let's speed this up a little bit. We don't want to be here all day. So let's do this at about a half-second pace. And this one we're going to put at, let's say, a 2-second delay between it, just so we can kind of see that break that happens. Let's run it and just see what happens. So we know x should probably start off at 0. And it increments by 1 every single time. And it only goes up to 9 because I don't have an equal to sign here. If I put an equal to sign here and I uploaded it, let me start that over again. There we go. Don't worry about this first one. That was just old stuff. So now it goes up to 10. Then we wait our second, or 2 seconds, and it just keeps counting up. It's counting up to 10 because we're including that with this equal to sign. What if I want to skip 2's every single time? Well, I could put, instead of x plus plus, I could do x equals x plus 2. What that's going to do is it's going to go into memory and find what x is, and in this case, x the first time is going to be 0. We're going to add 2 to it. Now this entire side of my equation is going to equal 2. We're going to assign that into x again, so now x holds 2. So what should print? There we go. I could have this count by 3's. I could have it count by 4's, by 5's. I could multiply it by 2 every single time. It's going to equal 0. Well, that's because I am starting with 0, and we're multiplying by 2. Multiplying by anything, that's still going to be 0. Well, I could change my starting value. I can do my starting value could be 1. Then this is going to be 1 times 2, which is 2. Then it's going to be 2 times 2, which is 4. 4 times 2, which is 8. In theory, that's what it should be. Let's see. 1, 2, 4, 8. Now what if I wanted to keep counting up? Well, just change this. Have it go up to 100 instead of up to 10. So there's lots of things we can do with our for loop. If I took this out completely, what would happen? I don't change my x at all. Well, if I don't change my x at all, it just stays at 1 the entire time. Remember, I changed my original one to 1. It starts off at 1. If I take out the semicolon, it doesn't like it. It has to have the semicolon. If I leave one of these conditions blank, it doesn't care, but it has to have the semicolons for it to work. All right, let's see, what else could we do here? If I wanted to, I could use an x that I previously used, or I previously declared, so I could have my int x right here. And I can give it a starting value. I'm going to change this back to x plus plus just to have it do something. So really all I've done is I've declared space for my x before I get into my for loop. That's really all I've done. Once we get into for loop, I still set it. Let's change it back to the original one. I set it to 0. So it starts at 0. I'm going to change this back to 10, and there we go. So kind of our original one here. Starts at 0 while x is less than 10, incrementing by 1 every single time. If I wanted to, I could also, out here, set it equal to 0, and I could take that away here. I still put my x here, saying that's the thing that I'm going to be using for my condition. That's the thing that I'm going to be incrementing. But I can set a value outside of here as well. So the basic structure that we usually show with for loops can be manipulated a little bit. And so it comes in handy to be able to figure out how we're able to manipulate some of these things. Int x. Let's start off with a big number now, 10. And let's say while x is greater than 0. Well, now I'm starting off with a big number and I want to go backwards. I can do my minus minus. What that's going to do is it's going to count down now. So it starts at 10 and it goes down. Is it going to get to 0? No, it doesn't, and it shouldn't because I didn't include that. If I wanted it to get to 0, I put my equal sign in. Another way to write my decrementing, my minus 1, I could write x equals x minus 1. What that's going to do is going to take what's in memory, x, so 10, subtract 1 from it, becomes 9, and that's the thing that we save. This is the exact same thing as x minus minus. So there's a bunch of different ways sometimes to write the same thing or to do the same thing. You're going to be the one to design your own code, so you get to choose what method you want to use. So start off with for loop, just something like this, and just play around with it for a while. Don't worry about blinking LEDs or anything like that. Put some prints in here and just see what's happening. See how this variable changes. It's very important to kind of notice how things work. And once we see that this variable can change, and it's nothing more than a number, this is just holding a value. Maybe I could use this value to do something. Maybe this could be a position of an LED. Or maybe I could use this as a value for my delay time. I could use this for all kinds of things because this x sitting here is just an x. Now let me show you what I mean by this. I could put my x in here for my delay time. And because 10 is really, really small, let's go ahead and say, let's start at x equals 0. Let's go until this equals 1,000. And we're going to do x equals x plus 100. All right, so take a look at this. Look at the entire condition. Start off at 0, while x is less than or equal to 1,000, and we're going to be changing by 100 every single time. So x should be 0, 100, 200, 300, 400, 500, 600, 700, 800, 900, and 1,000. That's going to be my delay time. So between my prints, they should start printing relatively quickly because there's no delay when it first starts. And then it's a 1/10 of a second delay, 2/10 of a second, and it should become slower as we print. And that's just me being a little bit smart about my design. and saying, you know what, this x, this value that's stored in x is nothing more than a number. And I use numbers all the time. I use them for my pin modes. I use them for my digital writes. I use them for my digital reads. I use them for my delay times. I use them for my if statement conditions or my while loop conditions. And so you can use this number to do anything. So just practice with these. Play around with them a little bit. They are a little bit daunting. They're a little bit more involved. I mean, there's a lot of stuff going on in here compared to if statements and while loops. But it's good practice, and it helps you understand what's going on within the code a little bit better.